Starting a steam tractor is no small feat, and the process of getting it up and running can take several hours. Today, we're following along with a fascinating machine that isn't an antique but a 3/4 scale replica of a classic steam-powered tractor. This particular tractor is powered by an engine that delivers 65 horsepower, and although it's a smaller model, it's still quite impressive. It's very similar to another case model I've previously introduced. In fact, this replica could very well be a scaled-down version of the Case 150, a model that was restored at a cost of millions of dollars. The first challenge in getting the steam tractor started is dealing with the valves. Before the machine can begin to operate, all the valves need to be properly closed. Some of these valves were initially opened to release any residual water. The process starts with adding water to the boiler. To do this, a handhold plate is removed, exposing the area just below the smokestack. This part of the tractor gets extremely hot, so it's crucial to have replacement rubber seals on hand as they wear out quickly. A new rubber seal is installed to ensure a proper seal before the process moves forward. Once the front of the tractor's open, you can see a network of black pipes and tubes. These are part of the exhaust system, which allows the steam and smoke to escape as the engine runs. There's also a larger inspection hole, known as a manhole, which is large enough for a person to crawl inside for maintenance. After sealing the handhole and ensuring everything is in place, the water level in the boiler is checked using a water gauge. This gauge gives an accurate reading of the water inside the boiler, ensuring it's filling up properly as the process continues. The next step is cleaning out the smoke tubes. Using a long metal rod with a brush attached, the team works to clear away soot and debris inside the tubes. This is a critical step, as any blockage in the exhaust system can lead to poor performance and inefficient steam production. After thoroughly cleaning the smoke tubes, the exhaust system is much clearer and the steam can flow more freely. The soot and ash are brushed out through the rear inspection hole, and the water level is checked once more to ensure everything is operating as it should. With the seals in place and the exhaust system cleared, the next task is fueling the tractor. The tractor has 2 large boxes located on either side, which are actually used for storing coal, not tools. The fuel in this case is coal, and it's necessary to feed it into the furnace to keep the boiler heated. The steam engine depends on a continuous supply of heat to create the steam needed to power the machine. Adding coal ensures the furnace remains hot and the water inside the boiler continues to boil. Once the fuel is ready, the next step is to start the fire. The ignition process involves lighting the coal and allowing it to burn. As the fire grows stronger, smoke begins to rise, and the water in the boiler starts to heat up. The amount of time this takes can vary, but it's an essential part of the process. As the fire intensifies, the steam pressure starts to build. To boost the heat even further, the steam valves are opened, allowing more air into the system, which results in a stronger flame and faster steam production. It's also important to manage the ash and soot that are produced during this process. Normally, the ash would fall into an ash pan underneath the furnace, helping prevent the risk of a fire outside the tractor. The system also recycles some of the heat from the exhaust gases. The exhaust pipes are designed to circulate hot gases through a set of additional pipes that run back into the boiler, adding extra heat and helping the water reach the necessary temperature more quickly. Another aspect that requires careful attention is the water level in the boiler. As the machine operates, water is gradually used up to create steam, so it's essential to top it off regularly. Fortunately, this steam tractor is equipped with water tanks on both sides. These tanks are used to replenish the boiler with water during operation, so the tractor doesn't need to stop to refill. Unlike modern machines that need to pause for refueling or maintenance, this system allows the steam tractor to run continuously without interruption. Finally, once everything is in place, the steam tractor is ready to go. But getting to this point takes a lot of time, preparation, and attention to detail. The combination of heating the water, fueling the furnace, maintaining proper seals, and ensuring the exhaust system is clear all plays a crucial role in ensuring the machine runs smoothly. With all these steps in place, this steam-powered beast is ready to start working. Starting a steam tractor isn't something you can rush. It requires patience and effort. And even though this particular one is a modern reproduction, it still involves a level of complexity that would make anyone appreciate the history behind these machines. Today, we're looking at a 3/4 scale replica of a classic steam tractor with a 65 horsepower engine. While it's a smaller version, it's almost identical to the full-size model, possibly a scaled-down Case 150, which was restored at a cost of millions of dollars. The first step to getting this machine running is checking the valves. Before anything can happen, the valves need to be closed properly. Some of them are opened initially to release residual water. The process starts with adding water to the boiler. To do this, a handhold plate is removed, which is located just below the smokestack. This area gets very hot, so it's important to replace the rubber seals regularly. A new rubber seal is installed here to ensure everything is sealed tightly. Once the front of the tractor is open, you'll see a series of black pipes and tubes, which are part of the exhaust system. These pipes are where the steam and smoke will escape as the engine runs. There's also a larger inspection hole, or manhole, where a person can crawl inside for maintenance. After sealing the handhole and ensuring everything is secure, the water level inside the boiler is checked using a water gauge. This lets you monitor the water level to ensure it's rising properly. Next, the team uses a long metal rod with a brush attached to clean out the smoke tubes. This is an essential step because a clean exhaust system helps the steam flow more efficiently, reducing the risk of blockages. Once the tubes are cleaned out, the steam can pass through freely and the system works more smoothly. The soot and ash are brushed out through the rear inspection hole, and the water level is checked again to make sure everything is in order. With the valves and seals in place, it's time to fuel the tractor. There are 2 large storage boxes on either side of the tractor, which are used to store coal, not tools. The coal is needed to fuel the furnace and maintain a high enough temperature in the boiler to create steam. This is where the real work begins, as feeding coal into the furnace keeps the fire burning hot, which in turn heats the water in the boiler. Now it's time to start the fire. Once the coal is added, the fire starts to burn and smoke begins to rise. The process of getting the boiler to the right temperature takes time, but it's a crucial part of the process. As the fire burns stronger, steam starts to build up. To help increase the heat further, the steam valves are opened, allowing more air into the system. This increases the flame and speeds up steam production. While the fire is burning, it's important to manage the ash and soot that fall out of the furnace. Typically, these are caught in an ash pan underneath the furnace to prevent any potential fire hazards. The system also makes use of some of the exhaust heat. The exhaust gases are routed through pipes that circulate hot air back into the boiler, helping it heat up faster and more efficiently. The water level in the boiler needs constant monitoring because it gradually depletes as steam is generated. Luckily, this steam tractor has water tanks on both sides, which are used to refill the boiler during operation. This means the tractor doesn't need to stop for a water refill, unlike modern machines that require frequent stops. The built-in water system allows the steam tractor to keep running continuously. Finally, once everything is in place, the steam tractor is ready to go. The combination of heating the water, fueling the fire, managing the exhaust, and maintaining the proper water levels ensures the tractor runs smoothly. It's a complex process, but it's what makes these vintage machines so fascinating. The feeling of getting this kind of machine running, with all the moving parts working together, is something you just can't get from modern electric vehicles. There's a certain mechanical beauty to it that still captivates, no matter how advanced the world gets. Starting a steam tractor is no small feat. The machine we're looking at today is a modern replica, but it operates on the same principles as the original steam-powered beasts of the past. This 3/4 scale version is equipped with a 65 horsepower engine, and while it's smaller, it closely mirrors the full-size model, potentially even being a scaled-down version of the legendary Case 150. The original Case 150 was painstakingly restored at a cost of millions of dollars, and it remains one of the iconic steam-powered machines from the early 20th century. To get the tractor running, the first step is to check the valves. These valves need to be properly closed before any operation can begin. Some were previously opened to release any leftover water, and the next task is to fill the boiler with water. The handhold plate is removed to expose the section under the smokestack, which gets extremely hot. To ensure a tight seal and prevent leaks, it's essential to regularly replace the rubber seals. Once the seals are in place, the water level inside the boiler is checked using a gauge to confirm that it's filling up as expected. After securing the seals and ensuring that the system is sealed properly, the team moves on to cleaning the smoke tubes. A long metal rod with a brush is used to scrub out soot and debris from the exhaust system. This step is crucial because a clean exhaust system allows the steam to flow freely, which helps the engine operate more efficiently. Once the tubes are cleaned, the soot is removed through the rear inspection hole, and the water level is checked once again to make sure everything is in proper working order. With the seals secure and the system cleaned, the next step is fueling the furnace. The tractor has 2 large storage boxes on either side which are used to store coal. This coal is essential to keep the fire burning hot, which in turn heats the water in the boiler to generate steam. Without enough coal, the system won't be able to build the pressure needed to get the engine running. Starting the fire is a delicate process. After adding coal, the fire begins to burn, and smoke starts to rise from the smokestack. As the fire intensifies, the water in the boiler heats up and begins to generate steam. To further boost the heat, the steam valves are opened to allow more air into the system. This increases the intensity of the fire, which speeds up the steam production and helps the tractor gain pressure faster. As the fire burns, ash and soot begin to fall from the furnace. These byproducts are typically caught in an ash pan, preventing any risk of them starting a fire outside of the machine. The system also makes use of the heat from the exhaust gases. The exhaust gases are routed through pipes that circulate hot air back into the boiler, helping it heat up more quickly and efficiently. Keeping track of the water level in the boiler is essential. As steam is produced, the water level slowly drops, so it must be replenished regularly. Luckily, this steam tractor has water tanks on both sides that allow the boiler to be refilled while the tractor is running. This feature means the machine doesn't need to stop to refill its water supply, a major advantage that allows it to operate continuously. Once everything is in place and the fire is burning hot enough, the tractor is ready to go. The combination of filling the boiler with water, fueling the furnace, managing the exhaust, and maintaining the correct water levels ensures that the machine runs smoothly. Operating a steam tractor like this takes patience and attention to detail, but there's something incredibly satisfying about hearing the engine come alive as the steam builds and the machine begins to move. The story behind these steam tractors is just as fascinating as the machines themselves. The Case 150, for example, was produced in very limited numbers, only 9 units were ever made. Over time, many of the original parts were lost or scrapped, but thanks to the dedication of enthusiasts, machines like this are being brought back to life. One such enthusiast, has spent years working on the restoration of these iconic tractors. Corey's journey began when he discovered the original boiler of the Case 150. Inspired by the challenge of restoring the entire tractor, he set out to learn welding, machining, and model making. Over the years, his company grew, and he eventually began the painstaking process of restoring the Case 150. This was a massive undertaking, requiring millions of dollars in expert craftsmanship, but Corey was determined to see it through. The steel components of the tractor were carefully fabricated, and the restoration process was intricate, making sure every part was durable and functional. The steam-powered beast, which once played a crucial role in transporting goods to railway stations and ports, now stands as a symbol of engineering ingenuity. Thanks to the hard work and passion of people like Corey Anderson, these machines are being restored and brought back to life, giving us a chance to experience the raw power that once defined an entire era of industrial progress. The effort required to restore these giant machines is a testament to the craftsmanship and dedication that went into making them in the first place. While technology has evolved, the mechanical beauty and raw power of these machines remain a fascinating part of our history. After experiencing significant wear and tear, it was decided to discontinue the production of the Case 150 steam tractor and shift focus toward creating models with smaller horsepower. However, despite the end of the Case 150's production, 9 units were made, and some of them share a very similar startup process to the earlier 110 series tractors I've discussed before. Starting the engine of these steam tractors involves a significant amount of wood, which is used to ignite the boiler. At the back of the tractor, you can spot 2 large black boxes, which are actually coal storage bins used for fueling the fire. The process is similar to how traditional steam locomotives are started. First, the boiler is ignited and then water is added. The tractor's water tank can hold up to 2.5 tons of water, and the 2 coal storage bins also have enough capacity to carry around 2.5 tons of coal. Operating the tractor requires 2 people. One person is stationed at the rear of the tractor to manage fueling and keep an eye on the fire, while the other person is at the front, controlling the tractor's movement. The tractor is quite large, measuring 7.6 meters in length, 4.2 meters in width, and weighing approximately 35 tons. When operating in low gear, it can move at about 4.2 kilometers per hour, but when shifted to high gear, it can reach a speed of up to 9.2 kilometers per hour, about the same as the speed of a horse. When this machine was first manufactured, it sold for around $3,600. By 1904, the machine used a boiler taken directly from the original prototype. However, the transmission gears were not strong enough to withstand the machine's power. As a result, all of the transmission gears had to be reinforced, which increased the price to $4,000 per unit. One of the key reasons production stopped was due to the issues with the transmission system, particularly the gears controlled by chains. These chains tightened and loosened to adjust the movement of the front axle, and it became clear that they weren't durable enough for the machine's demands. In 2019, this machine was put on display, where it showcased its impressive power by pulling 36 other vehicles at once. During the exhibition, the machine was often adjusted and tested to ensure all systems were working properly, including the gearing and steering systems. A great example of steam locomotive restoration can be found at the Dutch Steam Foundation, a museum dedicated to the preservation and repair of steam engines. This foundation specializes in restoring steam locomotives and their accompanying train cars. One of their featured exhibits is a German locomotive built in 1940, originally designed for high-speed passenger service. After undergoing extensive refurbishments, this locomotive was converted from burning oil to burning coal. The locomotive's boiler is crucial in the steam process, featuring a safety valve that releases pressure when it exceeds a certain threshold, preventing any dangerous overpressurization. Getting a steam-powered locomotive up and running is a highly involved process. It begins with burning wood to preheat the boiler, a process that can take several hours. The water in the boiler must be converted into steam, which then powers the pistons that drive the engine. This is a slow, methodical process that requires careful attention to detail. The fuel must be carefully managed, and the fire must be kept at the right intensity for the system to function properly. One interesting point is the technique used to add coal to the fire. The person in charge of fueling must carefully distribute the coal evenly to maintain a stable fire. The technician operating the fueling system happens to be left-handed, which results in him standing in a slightly unconventional position compared to others. Despite the awkwardness of the position, the process of adding coal is crucial to maintaining the locomotive's performance. When fully operational, steam locomotives consume large amounts of both coal and water. Every 50 kilometers, the machine uses up a significant amount of these resources. This high consumption rate means that long trips need to be carefully planned to ensure there is enough fuel and water to keep the locomotive running. The effort involved in maintaining and operating these steam engines speaks to the mechanical brilliance of the past, as well as the dedication of those who keep them alive today. The process of restoring and operating these massive machines requires a combination of expertise, patience, and passion. It's a testament to the engineering feats of an earlier era, and the efforts to preserve and maintain these historical machines continue to be a significant part of industrial heritage. For those who appreciate mechanical engineering, these steam tractors and locomotives are a reminder of the innovation that powered the early 20th century and the ongoing effort to keep that history alive for future generations. Operating a steam locomotive involves using a significant amount of coal, approximately 1 ton per trip. Because of this, steam trains are typically equipped with dedicated coal and water cars attached to the back. These cars are vital since the steam engine can only begin operation once it reaches the necessary temperature. But before this happens, the condensate that accumulates in the cylinders must be released. At the Dutch Steam Foundation, the main locomotive in operation is the 23023, a rare machine that has been carefully preserved after undergoing a complete overhaul to ensure it's fit for service. Due to the rarity and age of these machines, they're not run as frequently, especially the German high-speed locomotive 011075. Given its age and the difficulty of maintaining it, this particular locomotive is mostly kept in the workshop to maintain its condition. The station itself has long been abandoned and is now repurposed as a repair facility by the Dutch Steam Foundation. Here you can see a yellow locomotive briefly running back and forth within the workshop. The foundation houses a variety of steam locomotives, including the NS200 series, which is used for switching and yard work. Their collection includes 6 steam-powered trains, in addition to some diesel-electric models like the S200 series. There's something uniquely captivating about these steam locomotives that modern transportation often lacks. The exposed moving parts, such as the rods, crankshafts, and wheels, showcase a raw mechanical beauty that can't be found in today's more enclosed, streamlined vehicles. For those with an appreciation for mechanical engineering, these old machines have a charm that is both functional and aesthetic. It's a quality modern trains and vehicles often lose, with most of their complex systems hidden behind sleek exteriors. At the foundation, one of the exhibits is the NS200 diesel-electric train. Opening up its engine compartment, however, reveals that the original starting motor has been long removed. To start the engine now, they rely on a push car, a reminder of how older machinery, like steam tractors, requires hands-on work, especially when original parts are no longer available. This shows how the past was all about mechanical ingenuity and the willingness to maintain and repair these machines using whatever tools were at hand. A similar approach is needed for preparing a 1916 steam tractor for operation. One of the first tasks is to clean out the ashes and debris left over from its last journey. Unlike modern machinery, a steam tractor cannot just be turned on and driven. It requires regular cleaning and maintenance. After each run, the ashes from the previous fire are swept into the ash pan. However, this has to be done carefully, as improperly managed ashes could catch fire, especially if some of the coal hasn't fully burned. Once the ashes are cleared, the next step is to inspect the boiler. Removing the front cover of the boiler allows the operator to check for any dust or debris in the smoke box. A brush is used to clean this area, ensuring that the path for the smoke is clear. If not properly cleaned, the furnace will not burn as efficiently. All the pipes in the smoke box itself need to be thoroughly brushed out to maintain smooth airflow, which allows the furnace to burn hotter and faster. Steam is then directed through the system, helping to clear out the smoke and keep the entire system running at peak performance. This process is similar to how steam trains worked in the past. The quicker the smoke was expelled from the system, the hotter the furnace burned, and the more efficient the entire machine became. It's fascinating to see how these older systems functioned, where every part had a direct correlation to the machine operating before capacity. Today, with the shift toward modern, automated systems, much of that direct interaction with the machine has been replaced by more compact and less visual. In conclusion, maintaining and operating steam-powered locomotives and tractors is a labor-intensive process that speaks to the engineering brilliance of past generations. The careful upkeep of these machines, whether it's cleaning out ashes, checking the boiler, or fueling the furnace, shows the incredible complexity of these mechanical systems. While modern technology has certainly advanced, the raw mechanical beauty and craftsmanship of these steam engines remain unmatched. There's something irreplaceable about the tactile, hands-on care that goes into keeping these machines running, and it's this connection with the past that keeps steam-powered locomotives alive, both as working machines and as living history. Operating a steam tractor requires a thorough and careful process to ensure everything runs smoothly. The first step is getting the boiler up to the right temperature, which takes time and patience. As the pressure builds inside the boiler, the tractor starts to warm up, but it must reach the correct pressure before it can fully operate. During this period, it's also crucial to ensure all the moving parts are well lubricated. This is typically done with oil cups that slowly drip oil onto key components, such as the connecting rods. However, these oil cups often don't provide a clear view of the oil level, which can make it difficult to know when to top up. Some systems use glass oil cups to solve this issue, providing visibility into the oil level, ensuring that the lubrication is maintained and the engine continues to operate smoothly without excessive wear on critical parts. A vital step before the tractor can start is releasing any condensed water and excess steam trapped in the cylinders. This is done by opening the water drain valve. This valve, controlled by a handle, allows any residual steam or water that has condensed inside the cylinders to be expelled. This process, known as draining or venting, is not a one-time thing. It's essential every time the machine is started, ensuring there's no buildup of water or steam that could impede the smooth functioning of the engine. Even when the machine has been sitting idle for a while, this step needs to be performed to avoid damage to the engine and ensure optimal performance when it's ready to operate. Once the steam pressure is at the right level and the system has been vented, the tractor is ready to begin operation. You'll see steam being expelled in bursts through the smokestack as it works its way up, gradually clearing the exhaust gases. This process helps maintain proper airflow, which is crucial for efficient combustion. The intermittent bursts of steam coming from the stack are a sign that the engine is warming up and pressure is building, preparing the tractor to perform its tasks. As the pressure continues to rise, the engine gains the strength it needs to operate efficiently and safely. The next critical task involves managing the water levels in the boiler. As the steam is used, the water in the boiler is consumed, and it must be replenished regularly. A secondary water tank is used to supply additional water, but the process depends on the size of the tractor. For larger steam engines, mechanical pumps powered by steam are used to pump water into the boiler. However, for smaller steam tractors like this one, the increased pressure inside the boiler is often enough to push the water in. Even so, the water levels must be checked frequently. If the water level is too low, additional water must be added to ensure the system continues to operate efficiently. If neglected, the boiler can overheat, which could lead to catastrophic failure. The steering mechanism on a steam tractor is also quite interesting. Unlike modern systems, this one uses a chain-driven mechanism that tightens and loosens to steer the front wheels. While this system is a bit more rudimentary compared to the hydraulic or electric steering we're used to today, it's still very effective. The chain allows for controlled turns, and the tractor's wheels are designed with rubber for better traction, which is ideal for agricultural work in uneven terrain. This setup gives the tractor good stability, whether it's on soft soil or firmer ground. As the tractor begins to move, you'll hear the engine come to life. The sound is louder at first, but as the machine begins to run more smoothly, the noise levels decrease. The powerful steam engine, combined with the lubrication and pressure management, makes the tractor an efficient and reliable machine for tasks like hauling or tilling. The engine's power comes from the careful management of the steam pressure, which is directly tied to how well the boiler and engine have been maintained. Once the tractor has completed its work and is no longer in use, it's important to continue monitoring the system. You can't simply stop and forget about it. The boiler, exhaust system, and other components should be checked periodically. If pressure isn't properly released or maintained, it could lead to mechanical damage. Properly venting the system and releasing any leftover steam prevents pressure from building up too much, which could cause the system to fail. Even after the work is done, the tractor must be properly cooled down, ensuring that it's ready for its next task. This particular steam tractor was originally built in the early 20th century to serve the British Army in logistical support. It was used for hauling materials and supplies, playing a key role in operations behind the front lines. After being decommissioned, it was eventually sold to a private owner who undertook a lengthy restoration process. The restoration work involved bringing the machine back to life, allowing it to continue performing similar tasks for agricultural purposes, such as hauling hay and feed for livestock. While the tractor's primary role today is agricultural, it's also a popular exhibit at steam-powered machinery shows, where it demonstrates the power of vintage steam technology. The restoration of this tractor took several months, and today it remains a testament to the durability and ingenuity of early industrial machinery. It serves as both a working machine and a historical artifact, reminding us of the engineering feats that powered the industries of the past. With continued care and maintenance, this machine continues to operate, showcasing the timeless appeal of steam-powered technology.